this episode, we are going to talk about the electrical measurement tools. The tools that we are going to use in order to read AC and DC current, AC and DC voltage, amps, watts, and how to use each equipment in each specific case. The most important equipment that we are going to use is the multimeter, the digital multimeter. We are going to use the digital multimeter every day to check different functions. This is the most important equipment. I recommend try to buy a good multimeter, good brand. I love this brand, but there are other excellent brands, properly accurate. I love this. This is excellent. I have a good experience with Fluke. Fluke is in the marine industry widely recognized. Be careful. When you read voltage, the circuit should be power. The power should be on when you read voltage. Doesn't matter if it's AC or DC. When you try to read amps, of course, the circuit should be powered. When you read amps, intensity, amps, capacity, amps. When you try to read resistance, ohms, the circuit should be off. Off, turn off the circuit, no power on the circuit, no current flowing on the circuit in order to check ohms, in order to check resistance. Other important thing is the majority of the multimeters like this, the maximum capacity in amps of those multimeters is 10 amps. For example, this one say 10 amps, the fuse is 10 amps. That's the capacity of this multimeter, and the majority of the multimeters, they have a maximum capacity of 10 amps. What is the meaning of that? Later in this video, I am going to explain to you the procedure to read amps in a DC circuit. You need to be careful that the circuit that you are trying to read the amps have no more than 10 amps. That's very important, that's critical. Other equipment that we are going to use commonly is the clamp. The clamp, there are clamps like this for AC and DC. Normally I use the clamp to read amps in AC circuits, the flow of amps in AC circuit. This equipment, the clamp, is accurate to read amps in AC because this is basically a magnet, the positive and the negative side on the magnet. And when you pass the cable with power, AC power, it's easy convert the cycles in the AC signal into RPMs or into flow. For that reason, this clamp is excellent to read amps in AC circuit. Right now, we are going to check in the board for AC power how to use this clamp. This one is wonderful. This is the Sure Test. Sure Test. This equipment is used to check the integrity of the AC circuit in your boat or in your home. This equipment is used like the information that you have right now in the corner of your screen to check the integrity of the circuit, to check if the circuit have good polarity, to check if the circuit is properly wired, to check the resistance of the circuit, to check how much is the consumption in amps of that circuit in this moment, to check everything. Let me show to you a simple example. This is one outlet of this home, and we are going to connect right now our Sure Test. And our Sure Test indicate that the polarity, hot, neutral, and ground is okay. And the voltage right now is 120.2 volts. The capacity of this outlet is 15 amps and is used right now 13% of the circuit. The circuit have a 77% available. And this is the electromagnetic interference right now in this circuit is 0. And this is the resistance of this circuit is 0.48 ohms. Low resistance is properly wired, that circuit. And yeah, once again, hot, neutral, and ground are good. In other words, the polarity of that circuit is excellent. This equipment, the sure test, is excellent to check the integrity of the circuit. Other equipment that is widely recommended is the time domain reflectometer. On the screen right now in the corner, you have the definition of the time domain reflectometer. This equipment is excellent to identify in a specific wire where is interrupted the wire. From this point until the end of the wire, in what point specific is interrupted, or in what point of that circuit the resistance increase or decrease. That's wonderful. This is excellent because you say, okay, this circuit is open from 17 feet from this point. You follow the cable 17 feet, and in that point it is open. Or in that point, the resistance increase. You go over there, oh yeah, in this point, the wire is burned. For that reason, the resistance increase. This is the time domain reflectometer. ABYC recommend use this equipment in order to verify unwanted open. This is one of the ABYC questions on the test. If you are a good marine electrical technician, you need to keep in your tools the gauge meter. The gauge meter indicates how is that area affected for electromagnetic interference. This is critical. You need buy that tool. You need to keep in your minivan, in your truck. That tool is necessary, is mandatory. That's the gauge meter. Remember, we have three important equipments: the gauge meter that you have right now on the screen. The second one is the time domain reflectometer, in order to check where is interrupted the cable and where the resistance in my cable increase or decrease, time domain reflectometer. And the other one is the sure test, in order to identify the quality of this circuit. How is my circuit in voltage, in intensity, in ohms? That's the sure test. Other equipment that we are going to use is the tone generator or circuit tracer. What is the idea with this equipment? I want to know, I am working, for example, in the engine room, and I need found, oh, this is the cable, the orange cable that I need identified in the console on the fly bridge. How many orange cables you have in the fly bridge? A lot. With this equipment, you connect one end, the black end, to any ground, and this one to the beginning of the cable. And you start this one and you follow the cable. When the intensity and the light increase here, this is the cable that you are, oh, this is orange, this is exactly the cable that you need. With this equipment, you can check the integrity of the back end of a generator, or the integrity of any motor, AC or DC motor, the integrity of any winding. This equipment shall be used to check how is the insulation, of any winding of a DC motor, AC motor, back end of the generators. Any winding can be checked with the megometer. This is the only equipment accepted in order to verify the condition of the batteries in a battery. Use the multimeter to check the condition of the battery is not appropriate. The only tool recommended is the load tester. There are analog load tester with needle like this. In the chapter 4, I explain the procedures to check the condition of the batteries using the load tester, and I explain step by step how to use the load tester, analog like this, or digital like this. This one is excellent. This is digital, and this one is more accurate, because with this load tester, electronic load tester, the last one have integration with the internet, and you can print the information related with the battery, and you can send to the customer the information related with the battery. This load tester is excellent because you can apply, when you apply the load, and you apply the load specific for that battery, because this system asks to you the type of battery, if the battery is gel or lead acid, if the battery is connected on the circuit, if the battery is disconnected outside of the boat or the engine, and and immediately explain in the report if the battery is good, if the battery needs charge, if the alternator is not working. This element analyze if the problem is not on the battery, it's on the alternator. This is more accurate than the analog. Other important tool that we are going to use, especially if you are a surveyor, if you are an inspector, if you are a manager of a marina, you need the silver chlorine electrode in order to verify how is the bonding system in my boat, if the bonding system is working, or if you have a leak of current. This is an important tool, the silver chlorine electrode. I explained the use of the silver chlorine electrode in the chapter 10, when I explained bonding system and the galvanic isolator, the isolator transformer, and of course I explained in details the use of this equipment in my corrosion book. In different chapters of the corrosion book, I use the silver chlorine electrode. The silver chlorine electrode is the negative terminal, is the negative prom. I introduced that cable is a long cable, 25 feet. You introduce on the water, and this end is used here on the multimeter in order to replace the negative or ground. You put that one for ground, the silver chlorine electrode enter here, and you select volts DC, and right now you go with this to touch the bonding system or the C strainer or the metallic part that you need verify if it's properly bonded. Then I check the voltage in order to check the frequency of this outlet. I am going to check the voltage AC, and right now I am going to introduce the prompts of my multimeter in order to check the voltage. Okay, the voltage is 120.8 volts, and I have both terminals of the multimeter connected in the outlet, 120. When I am reading voltage, I switch to frequency, and immediately I have the frequency of the circuit, 60 Hz in this particular case. Alright, we are going to start to check voltage DC. We are going to select the voltmeter in volts DC, straight signal, and we are going to verify in the panel where should be connected the voltmeter. For example, normally I want to know if I have power in my panel. I connect the negative terminal in any part of the negative bus bar. This is the negative bus bar, in any part of the negative bus bar, and the other one in the positive. This is the positive bus bar where all the breakers have a common connection. This is the positive bus bar, and right now the reading is 12 volts, 0.42. 12.42. This is the voltage in between the hot, in between the negative bus bar and the positive bus bar. Now we are going to check volts AC in the AC panel. We are going to use the voltmeter here, and we are going to check in this panel. We are going to check volts AC. In this moment, this panel is activated. Let me check if I have power here. It's connected. Yeah. Okay, this is the short power. The short power in this moment is connected. You see the short power is connected. Let me verify if I have power voltage AC in between hot and neutral. 122 volts, 123 volts. Alright, and in the output of the breaker, let me check if I have a voltage. 123. Yes, this is the breaker for short power, this is the breaker for inverter, and this is the breaker for generator. Okay, what is the procedure to check volts AC? I select my multimeter in volts AC, and now I connect any terminal on the neutral and the other one on the hot line. What? This one or this one? Doesn't matter. I am going to use that one, the black one, for neutral, and the red one for hot line. Okay, the neutral is the white cable. I connect the neutral here and the hot over there. Okay, I have 122, 123. I am going to use the clamp. And the clamp have voltage AC or DC. This equipment automatically identify if the input power is AC or DC. For that reason, they have a AC and DC in the same position. And the last one is amps AC. I am going to select amps AC, and I am going to put the clamp in the hot line. I am going to put in this moment the light, the battery charger, and the outlets are connected, and I am going to check how much is the consumption in amps. Is 1.5 amps AC. 1.5. Look at this, it's 1.5. And now I am going to turn off the power. In this moment, open, because I don't have power. We are going to verify with the tester, with the megometer, if the winding is good or not good. Okay, for example, this winding is damaged. This is hot, neutral, and ground. This is the frame, and this is the winding. Remember, the winding don't touch the frame because it's separated with plastic insulation. The winding never touched the ground. Okay, I am going to check this winding. Okay, one terminal, the black one, should be connected to the ground. The ground is here, that's the metal. And the other terminal of the megometer should be connected to the face. This is the face. And I am going to crank. This is 0 and this is infinite. This is 0 and this is infinite. When I crank, if the needle goes to infinite, it's because the winding is in good condition. If the needle goes to 0, it's because this winding is damaged. Okay, I am going to crank. Goes to 0, it's damaged. Let me check this motor. One terminal to the ground. This is the case of the motor, the ground, and other one to the face. I say to you that this motor is running, but when you apply load, immediately the motor turns off. In that case, if the motor is working a little, when you crank it, the needle should be located in the middle, not properly infinite. If it's located in infinite, it's because it's excellent. If it's in the middle, it's like this. It's working, but when you apply load, turn off. Okay, let me crank. Stay in the middle in 10 mega ohms. Remember, in chapter 14, check that video. The minimum for a good insulation is 1000 mega ohms. In this case, is 10 mega ohms. For that reason, that motor starts, but when you apply a little load, the motor turns off.